everyone. This is a video walkthrough of some of the kind of basic introductory portions of using Jupyter Notebook and using Python. So if you're using Google Colab, there's no need to watch this one for now. You can watch instead the Google Colab walkthrough because there are a few differences even though they are very similar. So I'm starting here with the website for the school. You go to the 2020 school, you can see all these lovely links. I'll click Python programming, and there will be more added to this throughout the day and throughout the week. But you can see here there's been some material added. You have a few options for how you access material. You can download a zip file which has the Jupyter Notebook. So I'm going to do that. That will start downloading. There will also be a link through Google Drive, which will be added here later, or you can find all of this on a GitHub repository as well. And also all of this will be posted in the Python help Slack group, so Slack channel. So you have lots of opportunities to get access to all of the Python material that you need. And this includes for all the Python labs as well on other topics like satellite oceanography, and there are several more that are going to use Python. So, okay, so we've downloaded this. We can see it in the downloads folder. So we probably want to, I'm going to open up a new window here. Downloads. I have this zip file. I probably want to add this to my documents file. I'm going to put in COESSING2020. That will be good enough. So I'm going to move it to there. Now notice that I have a Mac. Many of you may have Windows machines, so hopefully you all know how to unzip a file. Here I just double click. Now I have this lovely notebook here. To open that notebook, I will go to Terminal on a Mac. If you are on Windows and you're using Anaconda, which you hopefully have watched the video for, and how to download and install that, you would be opening Anaconda Navigator or Anaconda Prompt. So I'm in the terminal here. Gonna cd to the directory that I need. And then I'm going to type Jupyter Notebook. So you would do the same thing if you were using Anaconda Prompt to open up your Jupyter Notebook. So I hit return. I'm gonna go ahead and open this in a new window. I have lots of windows open, working on everything to get this school going. Okay, great. And now this is the file that I downloaded, introductory Jupyter walkthrough. So I just click on it, it opens in a new tab in this browser. So for me it's Safari, it's whatever browser you want, it works in any browser. And then I have a notebook open here and ready to go. A couple things here, if you're on this page, you can also navigate through folders like this. You can create a new file by saying new Python 3. And there are a few other items here which I won't go into. You can ask if you have questions. So I have my notebook open here. Notice the name of the notebook here. If I wanted to rename it, I can do it here. I can say walkthrough tutorial. Now it's saved as that. And here we have these different cells. So you see I can click here on a bunch of these different cells, and I can evaluate each of these cells individually. So that's how Jupyter Notebook works. That's how Google Colab works as well. So you can see here that these are just text cells. So I'm just going to go through some of these steps here. You're welcome to do this without the video, or you can do it along with me as well. So we're going to learn some basics. So using Jupyter Notebook. So as I said, it's all, you use these different cells and you evaluate each cell individually. Notice how this cell is currently highlighted, and you can see up here in this menu, it says Markdown. So that means Markdown is basically text, if you just want to write text. So like here, I'm saying, oh, this is a walkthrough. First, let's understand how this notebook works. That's all text, that's not code. And so we need to make sure that Markdown is highlighted. You'll see if I change it to code here, it looks very different because it's trying to interpret it as Python code, which doesn't make sense because I just typed out a bunch of words. So it should be in text. And you can do Shift-Enter to kind of get out of the edit mode in the cell, and you can double click on it to get back in. You can also just click Run. So those are two options. Great, so if I double click, you can see that this is just text. You can add more. Here's more text. Shift Enter, there it is. Now let's see if we can create our own cell. And for that, we're going to use these buttons up here, this plus. So notice I have this cell currently highlighted. If I add a plus, it creates a new cell below it, and it automatically creates a cell that is a code cell. And that's just the default. So if I want it to be a markdown, I have to go to this menu, click markdown, and I can say, yay, markdown, shift enter, yay, that's great. You can also, if this were starting with code, you can do a little keyboard shortcut. As long as this is selected, you can type M, and it goes into markdown. So you can do some fancier things. So you can have some larger headers. So if we double click here, we can see that just by putting a pound sign or a hashtag and then a space, we get a very large header. In fact, that's the largest. Here, if you have 2, it's slightly smaller. If you put 3, it's even smaller. And actually, you can go on to 4 and 5. It gets smaller, and it starts to get italicized, and you can do all sorts of things. And actually, you can do italics here, too. There are a few shortcuts. You can look these up. So now if I do that, notice it's in italics. And again, we can evaluate these so you don't see those hashtags. I highly, highly recommend you use these. In fact, it's really imperative that you use these markdown cells. When you write code, you want to comment the code so that first of all, you can remember what you've done, but then anyone else reading it can also know what they're doing. So going back up to these buttons, I already showed you what the plus is. There are a few other useful ones, these arrows. So if we say arrow up, then it moves the selected cell up, and we can do it as many times as we want, or we can take it right back down. Run, you know what that does. Stop will stop the kernel, so stop everything running, and then you can restart the kernel. This is something, sometimes if something gets a little weird or it's acting like you don't think it should, sometimes restarting the kernel helps. So that's kind of nice to know. These are also very useful. You have if you hover over it, it'll tell you copy selected cells, paste cells below, and cut. So let's take this smaller header here. If I copy it and paste it, then we just get the exact same cell below. Super handy. If you did that and you didn't need it, like I don't need 2 cells that say smaller header, then you can just cut and it gets rid of the whole thing. A small note, if you cut something, if you cut this one and say, oh no, I didn't mean to cut that, it had all this information that I need, and you're welcome to just go back to the website. You can just download it again. You can get the notebook back. So don't really worry too much about kind of ruining the notebook here. The idea is that you can play around, and if you mess up a lot, just download it again, and you get the new one all over again. Also nice to know, you'll see it says unsaved changes. It does automatically save on your computer as long as you have enough space, but it doesn't do it quite every second, so it does it pretty well. But if you would like to make sure you save it, if you just got something running, notice that this says save and checkpoint. You can save it, and actually that makes, now it says last checkpoint a few seconds ago, and it just said checkpoint created. Then you can actually go back, revert to checkpoint. So now I have 1 checkpoint because I just made the first one, and you can go back. That's really nice. If you delete a bunch of things or you mess up a code that used to run, you can actually just go back to a previous version when it did used to run. So that's nice to know. Okay, on to some Python coding. So you can just do some basic Python coding without loading any libraries. Again, Shift Enter. You can just do some addition. You see that it prints the output right here, the answer. This is a square, so 7 squared. Another mathematical expression. You can print some words. So notice here I have to write print because it's a code cell. If I didn't do this, if I just got rid of this and said this, it will say error because it's trying to parse what I'm saying in code form. And it turns out that print and from are already functions in Python. So anyway, if you want to print words in a code cell, you say print. You can assign variables. Notice here I'm printing, and I can say the variable x has the value, and then print the value x. So that's kind of nice. You might want to use that in some of the labs that you're doing. But a lot of the actual interesting features that we can do are with other libraries. So here, let's import Numpy. So this is a numerical library. Allows you to do cool math and array manipulation and all sorts of stuff. So I say import Numpy. I could just write import Numpy. It would import the package the same way. But when I say as np, it gives me a shorthand so I can refer to that package as np. You can use whatever you want here, but this is kind of the standard terminology. And so now notice that I do np dot. That means access the NumPy library and find the sign function, and actually find the pi function as well, because pi is defined in NumPy. So you can evaluate that. You can create arrays, which is just kind of a series of numbers. So you can see here, a equals np.array. Here I just define it as 1, 3, 6, and 11. You can see that that's printed out here. This aRange function creates a list of numbers of 10 numbers starting with 0, so it actually goes from 0 to 9. This is a very important thing to note. Python starts at 0, not at 1. That will probably come up a few times. So when you say I want the first entry of an array, you actually want the 0th entry. But moving on, let's look at Matplotlib. This is a plotting package. Notice that we have this line up here. This % means that we're using a magic function. That's what they're called in a Jupyter notebook. There are a few of these. In this case, it allows us to plot figures right in line with the text here, so within this notebook, which is really nice. And then I import matplotlib.pyplot as plt, and let's make a simple plot. So notice I use NumPy to create these arrays that I can then plot. But it is always a good idea to label your plots. So let's go ahead and put a title, there we go, and we've labeled the x and y axes. Actually, we can make these a little bit larger. Let's say font size equals 16. There we go. Now we have x and y labeled slightly larger. Often you'd want this to be a little bit more specific, like date or time in hours or something like that. But yes, and also notice that the default color in Python is blue. Here I've changed it to red. So I've done that here with an R. You could also just write out red. And I changed the line style to dashed. There are all sorts of different things that you can look up to change these to make your plot look nice and pretty. Okay, so there are a few other useful libraries that we'll be using in this school. Pandas is one of them. It's great when you have kind of 2D data, so it's a really nice way to handle data when you have different columns, especially if they're in different formats. So if you have a list of dates and then you have a list of, precipitation values for every date, this is a nice way to organize that data. So let's just create, so notice we're importing the library here. A data frame is basically like a matrix kind of all of the data. That's the Pandas terminology for it, a data frame. And here we're just defining one. I'm not loading in any data at the moment. And I'm defining column A, so I'm labeling the first column to be A. The next one will be B, and so on. And in each column, there's a different type of entry. So in this case, we have a float number. This pd.timestamp means it's actually like in a date format. So it's an actual date. This is a series of numbers. This is an array. This we have some actual text. And here, we have the same kind of text string that will be repeated for all entries. And then here, if I say df, it prints out the data frame. So if I do that, then we see the whole data frame, which only has 4 rows and 6 columns. One really nice handy tip is if you do df.head, in this case it won't make any difference, but it only prints out the first 5 rows if you do that. And if you have a really long data set, like is often the case, and you don't actually want to print it all out because then you have to scroll for a long time, df.head is the way to go. And you'll see that in some of the labs, they already use this. So you'll get used to this in some of the other labs for this week. So I was saying these are all different kind of types. You can actually see what types they are if you do df, so that's the data frame that we saved, .dtypes, shift enter, and you can see what type they all are. So you can see that this one is in a date-time format. You have floats, you have integers, you have categories and objects. There are all sorts of things, many of which you won't need to handle this week, but you can know that you can put all of this data together, which is really nice. If you want to just print one column, let's say column E, you can do this and it prints it out. And also tells you what type it is. So that can be kind of nice. There are all sorts of functions, and you will be using Pandas in a few other labs. So this is just meant to be kind of an introduction, and you will get to use it more if you do other Python labs. Now, there aren't any more kind of exercises to do, but I want to talk you through a few more libraries. So Cartopy is one of them. Cartopy is a really nice plotting package. You may remember Basemap if you've been at the school in the last year or two. Basemap is very similar, but it's now being phased out. It's not being updated, and Cartopy is taking over. So Cartopy is something that helps you plot really nice maps, which, as you know, climate-related scientists, we like maps. So that is a very important library. Netcdf 4 is one that, if you just kind of want to quickly load a netcdf, which is in the form of .nc data, you can use netcdf 4. It's been used in previous years. Not sure if it's used this year in any of the labs, but you can look at examples from last year if you'd like to try it out. Xarray is kind of an alternative to netcdf 4. It's really nice. You can load data. You can load big data really fast, and actually has all sorts of things where it doesn't, when you say load the data, it doesn't actually load it into memory. It kind of will load it once it needs to. And so it's basically it's kind of a clever way to be able to manipulate large amounts of data, which is really nice when you're working with lots of model data or satellite data or something like that. You also can very easily just load data and print an annual, plot an annual mean, and you can do it all in like basically one line. Maybe it's two, but that's pretty great. So those are kind of the packages that we'll be using here. A few tips that I want to stress, like don't be shy, just play around. It's hard to mess these things up. And if you do, as I said, just download it again and restart. So yeah, mess around, try some new things, use the different buttons, see if you can figure out how it works. If you do get an error message, that's not a bad thing. So don't be discouraged. Error messages are often really nice. I have to say, usually when I get an error message, it's a typo. That's what I'm saying out here. And that's great because then it tells you that you're, what you've done wrong. Let's see if I can come up with a little example. Maybe instead of saying print, I say pring. Hello, this is a typo. And if I do this, it'll say, oh, name error, pring is not defined. And I'll say, oh, duh, because that's not a thing. Print, I'm all good. So yeah, look for errors. Usually it tells you if there's an error, so you don't really have to go through and reread what you've written. It'll tell you what the error is. So yeah, you also feel free to Google it. Look up your error messages online. There are lots of great help sites. Stack Overflow is a really good one. So yeah, lots of opportunities there. And yeah, so that's the end of this walkthrough. As I said, if you're using Google Colab, feel free to watch that one. It's basically the same notebook, but slightly tweaked for Google Colab. If you have any questions about anything with Python or Colab or anything, post them in the Python Help Slack channel. I will be monitoring it, and several others will be monitoring it as well. Because I live in Australia, I'll be awake during the morning in Ghana, so I'll be especially responsive then. But also, if you are a Python whiz, or maybe you did this exact same error before and someone asks it in the channel, feel free to respond. This is not something where it's just waiting for an instructor to respond. By all means, it could be a dialogue between participants as well. So please feel free to use the Python help channel as much as you want. Okay, so I think that is everything. If I come up with anything else, I'll let you know. Remember, we can save now that we've gone through it. Now we'll see that we have, it didn't seem to give us another checkpoint. Well, anyway, we can go back to our most recent checkpoint here. You can also download this file, so you can well, it already is saved as a .ipynb. You can save it as either a PDF or an HTML file, and then to a PDF, which often helps. You can also save it as just a Python script if that's helpful. Okay, I think that's actually what I wanted to say. So yeah, have fun, and I look forward to working with you this week. Thanks.